right, I heard you all loud and clear that my mic is quite quiet compared to the music. I'm going to leave my mic where it is. Just turn the music down. Actually, let me turn it up a tiny bit here. I have to figure out. That'll boost the volume a bit. So hopefully this is better for you all now. Yeah. All right, here I come. The train is departing. Kind of. Almost. Maybe. Get my notebook out. I'll turn the camera on me. So many things here. I'm not prepared for this at all, but I'm doing my best, everybody. Good morning, good evening, good afternoon. Hello to all of the Coding Train passengers all around the world. It is me. Hello to Julian from the UK, your host, Daniel Schiefman. And I'm here live on a Sunday. I forgot to turn the heater off. I'm in a very cold garage, but I have this electric kind of hanging garage heater, which I am now walking over to turn off. It makes kind of a loud noise. Later, I may have to turn it on again if I get kind of cold. That didn't work. Different switch here. There we go. I'm coming back. I'm coming back to view. Don't worry. Here I am. I'm moving a little slowly. It's a Thanksgiving holiday weekend here in the US, and I went to visit some family, and I slept on a very small twin bed for one night, and like half of my back, the muscle is all like contorted and twisted. So after my whole rest of the afternoon today, I think I'm gonna be doing some stretching. I'm an old man I'm not, in many ways. I'm very young to be like, I have no interest and I'm not qualified to be president of the United States. Why am I even talking about this? But for YouTube, for doing this thing that I've been doing for well over 10 years, 20 years, got something stuck in my teeth. I was quickly having a little toast and peanut butter to have some energy here. Whew, it's been a while. I know. I don't know what happened to 2023. It's almost over. I was feeling a little bit better. Now I have this a list of goals and plans that I made at the beginning of the year, and there surprisingly are some things checked off here. So I feel like all is not lost, but it has not been the most. I mean, it's been a very productive year for me, and I will talk about the Nature of Code book, which has been my focus for this year. Which has really reduced the sort of productivity, the content, if you will. Because what else do I do here on the Coding Train but make content? I mean, that's what we're all here. We're just engines of content, to make content, to consume content. It's all content. I haven't made very much, I would like to say, educational, possibly slightly entertaining tutorials. But I'm here. I'm trying to get at least 2 more live streams in before the end of the year. Maybe start thinking about goals for 2024. I do believe in my heart that 2024 will be more Coding Train focused, because there's a fly that's really interested in my light over there. So hopefully this won't be too distracting. But with the Nature of Code book wrapping up, I think that I would like to turn back towards videoing as opposed to writing. After all, I could just have some language model take care of all my writing for me in 2024, but maybe my humanness still comes through the camera somehow. Although I am working, actually, let's not mention this just yet, but coming soon, something interesting for all of you. Where, when can we buy the book? So let me not talk about the Nature of Code book just yet, because I do have an actual sponsor of today's live stream. You really should thank the sponsor greatly, because sometimes I don't take a lot of sponsors. I'm really excited about this one. It is a company called Upper Story, and as soon as I saw, I know you're not seeing this right now, as soon as I saw this game called the Turing Tumble, named for Alan Turing, don't get confused. There's a lot of turning going on, but this is a game named for Alan Turing. I was really excited. I desperately wanted one of these to play with it, to try it with my children. In a bit, let's see if I can get this camera to work. I'm going to show you it live in action. I've got it over there on a little extra table. It's holiday time. If you're looking for a holiday gift, if you know some children, some adults who want to get into computers, want to learn how logic gates work, all that stuff. But maybe you need to take a break from your screens. This is an entire mechanical. This is a Turing complete computer sitting there on the table. I'm gonna talk a little bit more about it. But if you're interested in learning more, right now there's this website that you can see, upperstory.com/Turing-Tumble. But better yet, there is a link in the video description. I don't know if there's any moderators around. I'll have to do this myself at some point, but I'll put a link into the chat and maybe even pin it as well. Am I ever going to be? It's going to be the most tech-savvy grandpa. First of all, I'm not that far. I mean, I'm hopefully very far. But who knows if I'll ever be a grandpa? There's a possibility. I think I'm like not very tech savvy right now. I mean, my ability to do things on the computer in any kind of cutting edge, intelligent way, pales in comparison to what the two youths that's another reference. The youths are doing these days on YouTube. Boy, there are a lot of incredible people making technology, coding, educational content on YouTube. Anyway, check out Upper Story, link in the description. Let me set the table for what I want to do today. Usually I do the little sponsor segments in the middle, but I think I'm actually going to do it right at the top because it's kind of fun. It'll be a fun game for us to play as a little icebreaker, and I've got it set up over there on the table, and that way I can then move the table out of the way and get back to some whiteboarding if I need to. So I don't have my systems up and running fully for all of the different ways I like to look at the chat. I keep looking over here, but I don't see any chat. I just see my soundboard. Welcome on today's episode of The Coding Train. I'm going to be here without knowing what I'm going to say next. There's a camera over here. That's exciting. Got some stuff going on. Vince asks, do your kids code? Yes, they do. I think they're a little like, enough with the coding already. Oh my goodness, coding this, coding that, blah, 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 blah. But they're interested. They do. Kids these days, they've got their coding education in their K through 12 schools, at least here, which was very different than my experience. All right, so let's think about things. Let's come back to here. So one thing that I am curious about, I really would like to do some coding today. So I'm going to talk about, we're going to look at the Turing-Tumble game. Step one, let's make a list. Okay, I'm glad you like the background. Thank you to Stephen Wolfram in the chat. I don't have my whistle. I don't have any of my props. No, I got this one. Ooh. Okay. Ooh. Okay, so we're going to start with Turing-Tumble, today's sponsor. Thank you to Upper Story. We are going to move from there and maybe look at, and MB Lab is asking, what is the plan for today? We're figuring it out together. I'm going to be here till approximately 1 p.m. Eastern. So that's kind of a bit of a hard out for me. So that's an hour and 45 minutes. I'd like to take a little 5-minute break somewhere in there if possible, if you'll be so kind to allow that. I would like to look at the passenger showcase. We'll look at some recent additions to the passenger showcase. Thank you to all of you who've been submitting your projects. I would like to give you an update on the Nature of Code book. And, usually you would think it makes sense to make my agenda before I start streaming, but I have spent a very long time getting the audio routing properly so that I could have the soothing tones of some royalty-free music. Thank you to Epidemic Sound, which I think is this track is from that I subscribe to. Nicole says, I really need to submit to the passenger showcase sometime. And yes, you do. In fact, maybe you want to do that today. Make that your little Sunday activity. Although it's a Sunday, any day, maybe after, if you're watching this, maybe after this is over, you would close your computer, spend some time with your thoughts, with nature, with a book, good book you can just curl up in. That fly is coming to get me, everybody. Let's see if I make it through this. Okay, do Tetris. Wait, oh, Stefan Wolfram, that's actually your name? I'm so sorry. I just assumed that was somebody with their YouTube name as like a play off of Stephen Wolfram. But we actually have the real life, honest to goodness, Stefan Wolfram in the chat today, which is kind of great because the thing that I was planning to code today, because I know my recent live streams have been a bit more just chit-chatty, but I would like to, the two things I'm thinking of coding today, one is the Wolfram, as an homage to our friend Stefan Wolfram, the Wolfram 1D CA. And then the other thing I'm thinking of doing is looking at a JavaScript library called Transformers.js and doing some experiments with embeddings and text. Well, this is a really long track that I just put on arbitrarily behind me. I love Dustin's comment there. This is the adult version, which, by the way, got me a little scared at first. I was like, oh my God, the adult version sometimes means something else to me. Now I'm already getting like incredibly embarrassed. Just of everything I loved and enjoyed from PBS learning shows as a kid. I appreciate that. Okay, so I gotta shut this music off. Okay, I just realized that most of my props are in a tote bag through several doors away from this garage where I am, because I had packed them all up for this thing that I'm working on, and I forgot to bring them back. So my random number book, all those things. So one thing I'm curious about, well, also we've got, let's look at this. So let's just look at this list and see if there's anything here. So let's have a little recap. What was accomplished and by the way, the reason I keep looking over this way is that's where I have my monitor at this YouTube chat, and when I turn, this muscle in my back gets a little poked. Oh, and I forgot to. Will I be doing a showcase of the Hacktober submissions? Lost Sorcerer, what an awesome idea. So I forgot about that. Yes. All right. And by the way, I do also have out of the corner of my eye the Discord member chat. So if there are any important or like comments or questions or something going on, if any of the Discord members who are in the live chat supporter channel want to put a message there, let me know. I'm not going to be seeing it right. So maybe reduce the, we'll figure it out as we go. But I just saw that Fishy posted hi, so I did see that. And I see that we have someone from Morocco today. Welcome. One of the things that I say this a lot that thrills me to no end are the international global viewers of the Coding Train. I mean, I appreciate you if you're like watching this from, Queens or something. That's awesome too. Wait, what? Oh, I'm like, what is that sound? I'm like, my computer is about to explode. Do you hear it? So I'm using this software that I love called Loopback, which is an audio routing software. And the way that works is I have an iPad over here with sound, music and sound effects, and it kind of routes around through this audio interface into this laptop, and then I route it out into this PC streaming computer, and it comes into Open Broadcast Studio. Wow, Carl, it is very cold here in New York. So, but I forgot that I just this is a new computer that I haven't streamed with before, and I just quickly installed the trial of Loopback, and I've bought Loopback software, so I need to find my license code. So I don't know if I'm going to do this right now. Let's see. Okay, so let me come back to here, and I might have to dig into my email. Where would I have purchased it? Which email address would I have used? We're about to find out. Okay, let's. Oh boy. Will you all indulge me for a second? You know what? I'm gonna okay, now my email is like on the screen. This is terrifying. Let's just see if it's really obviously fast. Rogue. Loosebap license key. Yes. Could this possibly be 2016? Is that gonna actually work? Daniel Schiefman, my code, unlock. Older license key. But no, I've definitely purchased a newer one because I remember doing this. Recovered license information in 2019. Maybe this is it. This is like, wherever there's somewhere on the internet best practices for live streaming, whatever I'm doing is not it. Oh, that's the same. All right. Hello at Rogue Amoeba. Maybe I actually just need to purchase a new one. Loopback. Receipt 2019. Okay. Receipt. Okay, hold on. I did purchase. I've got a new license code. Okay. I've got it. We've got it, everybody. Unlock. Yes! Oh, whoop, wrong button. Success, everybody. Loopback has been unlocked. Thank you. Look at this. I get a whole certificate and everything. I feel very proud of myself, and I'm, in honor of this moment, going to play. Oh, wow. You can't hear that at all. I made that very quiet. Okay. Let's see. Okay, so what were we? That was an adventure, yeah. Coding challenge idea, thought planner. Okay, that's interesting. Nick is writing from Toronto. Yes, happy belated Canadian Thanksgiving. MB Lab asks, will you be doing the January challenge this year? Let's address this, and then we gotta get moving on this list of things if I'm gonna get to anything. Wow, and we've got Jog from Algeria watching. That is amazing. I don't know if I pronounced your name correctly, Jog. Feel free to spell it phonetically for me in the chat. Even if I miss it, maybe I'll try to go back and read the chat later. All right, so we've got to get moving here. Yes, January. So if you're not familiar with January, let's take a look. It's coming up. January is a month. January is a month that has its days in it, and every day there is a new generative art prompt. It's one I've been trying to participate in some way. 2 years ago, I actually did something every single day. Last year, I didn't do anything any of the days, but at the end of the month, I did a January speed run as a live stream. That was really fun. So at a minimum, I absolutely want to do a January speed run again. But I have this idea. I don't know if you know this, but there is a Coding Train TikTok account. Also, YouTube has shorts. I don't really use them. I haven't figured out a way to use them or to make short form content in any way that's fun and useful. But I thought maybe as an experiment in January, for January, I would make a short video every day based on the prompt. And I would do them completely on my own. Like any editing, production, capturing, I would have to do it on my own just as a way to learn. Oh, and we have a new member. Hello to Munzer. Welcome. You have just joined the conductors of the Coding Train. Welcome aboard. For your membership, you will receive a little packet of stickers. Guess what? We do the sticker mailing once a year. And if any of you have received your stickers, because we've been sending them out the last few weeks, please say so in the chat. Would love to hear that you got them if you like them. But the mailing happens once a year, but you're just under the wire Munzer, if you look into the YouTube community posts, now that you have the members one, you will find one where you can sign this form with your information and we will send you stickers. So yes, and welcome to Mohammed in the chat, and Yash, and AI guest. I'm so glad that AI is here. All right, so let's get started, and let's start off with the first segment of today's live stream. This is a sponsor, in case you weren't clear about that, but it's something that I would 100% legitimately cover on my own. I mean, honestly, like, I just wanted to buy one. So when they were like, okay, we want to sponsor, we'll send you one. I mean, nothing could have been a better alignment of things. So I want to show you a little bit about what this is. It's, whoops, I'm having trouble. I'm going to walk over here. I'm like a little game show host here. So this is the Turing Tumble, again, named for Alan Turing. So I don't know how many of you are familiar with Alan Turing. I actually had the chance to visit a place in the UK called Bletchley Park. And it is where Alan Turing cracked the Enigma machine, the Enigma machine is the German code thing that they broke in World War II. There's a whole movie about it. The Imitation Game, it's called. Alan Turing, quite famous for the thought experiment of, can machines think, and this so-called Turing test, which certainly is quite relevant today in today's world of language models and new AI technologies. But I think it was in the 30s, probably 1939, that Alan Turing came up with the idea of completeness. So a Turing complete computer is one that, and this is, think about this. We're talking about the 1930s. I think the paper is maybe 39. I got to go fact check this. Someone can fact check me in the chat. But think about this. How did Turing think about the idea of a Turing complete computer before there were even really computers? That fly is really coming to get me. No, I will not. The sanctity of the Turing Tumble board is quite, and I also realized, okay, I'm going to talk to you about Alan Turing while I do some busy work here of just like setting up something that I'm very clumsy. Oh boy, I'm going to definitely be fired from my upper story desk. Okay, so all right, so a Turing complete computer, the idea is with infinite time, without finite time and resources, essentially. If you think about like a tape, a tape that you could process through and essentially, perform computations with it. It's very hard for me to talk and concentrate on what I'm doing. But the idea of a Turing complete computer is one that, given an infinite amount of time and resources, or memory, you might think of it as, could perform any computation at all. And amazingly, this toy, board contraption, mechanical contraption, which I had a lot of fun putting together. By the way, just assembling this thing was quite the challenge for me, is a Turing complete computer. And one of the things about it, and what I love about this game, so first of all, let me come over here and just explain to you how this works. Let's see if this will work. Great, perfect. So I have over here, the board itself comes with this book, the Turing Tumble Puzzle. Oh, it's upside down. Okay, let's fix that. That's one button. Come on alive. There we go. The Turing Tumble Puzzle book. 1936, says Dustin, was when Turing published the paper on the hypothetical machine. 1936. Okay, so are you hearing lots of audio pops and snags? People are telling me. So let's see. I could get a little bit of info if people are having audio issues, and I will try to fix those. Hopefully it is at least you can understand what I'm saying. But I'd love to know. So what I love about this is, first of all, So the book comes with a diagram. Now there's all these different elements. I'm not going to be able to go through and do everything. Plus, I wouldn't want to spoil it for you, frankly, to be perfectly honest. So I barely want to. I want to show this to you because it's so cool, but I don't want to show you too much. So this, I had a lot of fun putting this together. There is a whole story, a graphic novel essentially that you can read. But I've been doing this with my son, who is 15. Yeah, he turned 15 recently, which is why I had to pause there to remember. We were having a lot of fun putting this together, looking through the story, and then as integrated in the story, you start to learn about this machine and how to play. And there are a whole set of puzzles. And immediately when looking on this, I realized like, oh, this is just like a computer. And one of my favorite parts is this I forgot what it's called. It is it's going to introduce a new part here. New part. So this new part is the bit. So I have it here. I'm going to show it to you. Whoops, wrong button. I'm getting back and used to this. No audio problem, somebody told me. Okay, that's good. So this part right here is a bit. And it can be in one of two states. And as you see, as soon as I get this thing going, these marbles will fall. And when they hit this bit, it switches to another state. So essentially, if you've ever studied, and you don't, the whole point of this is you don't need to, but I'm connecting it to the audience here. If any of you, I know a lot of you are maybe current students or maybe studied computer science or took a computing course. If you ever studied assembly language or lower level computer, you might have computation. You might have learned about what is a logic gate? What is a bit? What is a register? How do computers store information? One of the puzzles in this uses these bit pieces to count, right? Because if they're all zeros and ones, you can count in binary, and you could essentially program by moving these other parts. There are gears, there are all these different parts. So let's just give you an example. I've already solved one of the puzzles. Let's look. This is puzzle, I can't remember. It's one of the early ones where basically the input are blue and red marbles. And what your goal is to have a particular output that will land here on the bottom. And for this particular puzzle, the desired output is blue, red, alternating colors. So I think I've set this up correctly. It's definitely which position this in is very important. I believe if I have it in this position, the blue marble is going to fall down this side and trigger another blue marble, which would give me 2 in a row, which I don't want. So I've got to flip the bit this way. I'm going to click this to start it. And here comes the blue marble. It's going to click this, which will send a red one. And the red gets sent to the other side. I did it. Oh, so first of all, this to me is like the most satisfying sound ever. And I'm going to let this play while I go and look to see if there's some other things I want to tell you about this machine. Right. So I had some notes here. So this is a computer. It's Turing complete. So any process that you could do on your computer, on your phone, you could actually program on this. I mean, the limit here is the fact that this space is very finite. So I only have this much to work with. But what's really exciting about this is just how that like explodes your mind to realize that if we had an infinite amount of space for this contraption, we could really program anything. You could have ChatGPT could run on this basically. Let's see. So the other thing is there is something called the Turing Trust, which was started by Alan Turing's family, strives for a world of equal opportunity with technology-enabled education for all, and a portion of each purchase goes to support the Turing Trust. I wanted to remember this. So Upper Story's model makes this game as endless curiosity. They have other games. There's one called Spintronics. But really, like for me, what is really exciting about this is just the pure satisfaction and joy I have from like watching the mechanical nature of this play out. If I really want to just put all the marbles back and look, we got red, blue, red, blue, red, blue. But the other thing here, I think, for if you work in education, if you just want to learn yourself, if you know a young person or who is just getting started in computing, wants to learn more about how computers work, how does counting and binary work, how do like the lower levels, what do those transistors really do in a computer? This, and it's holiday time. This is the perfect gift, I would say. So if you're interested, there is a link in the video description. If you use the code CODINGTRAIN, all caps, one word, that will get you 10% off purchase of the Turing Tumble. Certainly, if you do end up getting one and enjoy it, I'd love to hear from you, hear about what your experience is. Let's see, I thought maybe we would do one puzzle. The one that I thought might be kind of interesting to try. Let's see here while we have a little time. The Aria asking for the link. It's in the video description. I should post it. Right. And Kathy writes, reminds me of the game of life as a computer, which I also think is a really apt analogy. And it's in many ways, it's like perfect that what I want to do is the Wolfram Cellular Automata today, maybe as a coding example, because I was thinking like, oh, this is just like the Wolfram CA, which is this system of cells that have a state 0 or 1, and the cell state is basically determined by its neighbors, which is in many ways what's playing out there. Okay, Dustin says, I like the graphic novel style of the manual. I do as well. So let's see. So let's look at the one that I pinpointed that I thought might be interesting to do would be challenge 18. I've done all the way through. Can't remember where I got to. I didn't get up to challenge 18 yet. But this is one. The reason why I thought, so I'll just read it to you. Challenge 18, entanglement. If the top bit and the bottom bit start pointed to the right, put a marble in interceptor T. Otherwise, put a marble in interceptor F. So this is like programming an if statement, essentially. So the way that I need to do this, let me put this back over here. And I'm just going to bring the book with me. Just in case I need a reference here. So I'm going to take, I'm very clumsy. I'm going to take all these off. How much is my bald spot showing? Very self-conscious. Let's see. Okay. Oh, my back. Oh, okay. I'm okay, everybody. All right. Now, looking at this. Oh, these are not supposed to be there. So what I need are, the setup is I need 2 bits. I need another one of these. Where are my bits? Ah, here they are. And so I need another one. Direct 2 below. It goes here. This is what I'm looking at as my reference for the puzzle. And then I need a true and a false. These are called the interceptors, I believe. So they will stop the marble from reaching the bottom. That's one thing that's too bad about this puzzle, but the first one really showed it, is the whole thing just goes. So this one goes now here. And this one goes here. Okay, I think that's right. Yep. So now I need to figure out if, and I think I can just put a few up here. So what I want is, if the top bit and the bottom bit start pointed to the right, put a marble in true. So with this starting point, the marble should land here, which I first assume I need to catch it, for it to come down. So this would catch it coming down. Then it would click here, go like this. So I think I can just catch it coming this way. You can try to play along with me here. And then it should, oh, wait a sec. No. I think I have to do this for it to then come down and drop. Is that, oh, wait. Is that enough? Oh, no, because I want to drop it in, they're both pointed to the right. So I want to drop it here, it comes in here, then I catch it here, and it should then fall in that. Let's see if this is right. So now them both pointed to the right. Yes, okay, so I got a true. Now, am I doing and or or? We'll see. Now if they're to the left, if this one's to the right, now it should go into false. Anything else is false. So basically I'm doing an and operation. This is like programming an and operation. Because if both of these are to the right, it should fall in here. If either one or both is pointed to the left, which is like on, I would say. If they're both on, I should get true. If either one is false or they're both false, it should go here. So certainly if it's pointed to, oh wait, no. I did it wrong again. No, pointed to the left. Yeah. So this is going to get it this way. So now this gets it pointed to the right. Pointed to the right is on, and they go into the true. So now if this one's pointed to the left, I can easily just take it this way. No, I wouldn't want this to happen. So I need to take it this way, I think. It'll go there, and then this will fall this way. Can I then just catch it here and then catch it here? Will this work? Okay, so now let's point them both this way and let's see. Okay, so I got it there, but now what if one is pointed to the right? Will this work? Yes, okay. So, and then what if this one is pointed to the right, but this one's pointed this way? What's going to happen? That should be fine, because it won't activate this. So I think I did it correctly. Let's put a few more. Basically, let's just prove. Let's prove that this is a AND operation. Okay, so how many possibilities are there? 4. True, 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 false, false, true, false, false. So let's do all of those and see if it works. So this is true, true. Correct. This is now false, true. Wait, no. True, false. True, false. Correct. This is now true. So this is now false, true. Correct. And then false, false would be this. Beautiful. All right, I did it. So this is what I mean. I don't know. Maybe this is not that much fun for you to watch, but I can tell you with genuine excitement and enthusiasm that this is really fun to do. So, so again, I'll wrap this up here. Check the video description. There is a link there. It's upperstory.com/Turing. Turing for Alan Turing. I got to find my photos of when I went to Bletchley Park. That was in 2015. I went there twice. So I was in London for like 6 months basically, and I went to Bletchley Park and I was like, I'm going back here again. I just like everybody who came to visit me, I'm like, I'm taking you to Bletchley Park. There's a computer museum there. It's fantastic. But if you can't go to Bletchley Park, this Turing Tumble will get you that a little bit of that feeling of like what it is to work with a analog mechanical computer. So go to upperstory.com/Turing Tumble. You can use the coupon code CodingTrain for 10% off, and check the link in the description. Okay, the audio is usable, but the pops are really annoying. Yeah, audio pops. Okay, there is some audio issues. Okay, so I am going to now see what I can do to fix my audio issues. One thing I will do is mute myself first. All right, let's see if that resolved it. Okay. So one thing, I did a few things, and one thing is I have muted the audio that comes from my the like music and sound effect stuff, because maybe the audio pops is coming from there. They're very rare. The desktop is fine on it. So all right. So hopefully that is resolved. and we can move on. Let's look at, so actually, before I move on, it's 11:45. Am I still, I'm not muted anymore. Okay. So what I would like to do is put a poll. Can I do a poll from here? Start a poll. Okay. What should I code? Wolfram 1DCA or Transformers.js embeddings cluster. This is AI. This AI example. I'm going to do it this way. All right. All right. So I put a little poll. It's coming from the lapel mic, someone says. Still hear them. Well, the other thing I could do is just clip this to a different spot. Let's try this now and see if that fixes it. Oh, sweater rub. Okay. So I clipped it to a different spot. And actually, let's get it even further away from the sweater, which maybe, and unzip this a little bit more. All right, let's see if that fixes it. Sorry, I'm moving a little bit slow. Okay. Well, that means I can turn my music thing back on just in case. All right, so we're going to see what's happening with the poll. I'll let that run. But while I do that, I would love to show you, let's look at some things that have been posted recently from passengers of the coding train. So I'm going to go to GitHub coding train, and we're going to look for the coding train logo. And so this, if you, oh, and you're not seeing it, so let me come back here. So this is a particular GitHub repo that has a P5 sketch that renders the newest coding train logo, this little like ASCII art-like simple drawing of a train. And if I click here and run the sketch in P5, you can see that the logo is there. So this was something that I set up for Hacktoberfest as a way for people to make their first open source contribution to this repository. But certainly this is still open for contributions. And there's more information here that you can read about and how to submit. But I'll just show you a few of the things that people made. So this is an animated logo made by Deepam. So basically took that P5 sketch and animated the paths of the different parts of the train. This is a 3D printable coin, which was created by Dan the Lost Sorcerer. So I don't know, is this actually 3D printable? Does this thing exist? This is a repo about it. Yeah, it looks like there's a model file. There's some like code here, which looks like it's written in some other like language that I don't know for doing 3D modeling and extrusion. So this is really one I didn't see that this was like fully documented in such a wonderful way. And you can see this here. So I don't know if anybody actually 3D prints this. I would love to see a photo of it. Wow, we're really at 50% here. This is not this poll. I might just have to decide myself. I like to do whatever the opposite of whatever the poll says. Okay. And then we have this moving with smoke from Kathy. So this is animating the coding train. I would say this is probably using the particle. Well, I don't know if it's using it, but certainly it has the same visual behavioral quality as the particle system example. Kathy also made a 3D logo. This is using P5 geometry. So if you've been paying attention, there's P5.js version 1.8 is now out. And P5.js version 1.8 has a lot of new features, particularly around 3D. P5 geometry, I'd love to do some tutorials and videos around P5 geometry. And then there are also a bunch of ports, a Java port to processing and a Python port. And did I miss anybody's? There's a couple issues here. Let's see. just talking about the port, the brainstorming list. I don't see any pull requests. So if I miss anybody's, please let me know in the chat. Oh, Lost Sorcerer is here in the chat. Haven't printed it yet, but will soon. So Lost Sorcerer, when you do print it, please let me know. I don't know, share it as a Passenger Showcase project, a photo in this repo, on social media, wherever things can be shared these days. Okay, let's go now to thecodingtrain.com. Whoops, and let's talk about what's new there. So, and then I'll take a short break, and we'll do some coding for a full hour in the second half of this live stream. Okay, so first of all, Coding Train website. If you have not had a chance to visit it, what are you waiting for? This is where you can find all of the coding challenges. Actually, I just realized, thank you to Kathy, who does a lot of work helping to maintain the website. And I realized that Kathy had updated the featured Passenger Showcase projects and challenges. So let's merge this right now. So that will appear live on the site momentarily. And I can talk through what is on the website. So you can see that the most watched, consumed content. Is anybody a Patrick Willems fan here? We got any Patrick Willems Coding Train crossover going on? Patrick made an amazing video about the word content, and so I'm constantly thinking about it and finding myself saying content and like having this like sickening feeling inside. But in terms of the videos and material that I've made, these coding challenges have been the sort of long-standing heart, the beating heart of the Coding Train, and it used to be the thing that I had like a new one every week, sometimes 2 per week. But I kind of just, I don't know, someday I'll get back into the rhythm of these again, but there's only been 3 in 2023. Hopefully we'll get in at least one more. Last 2022, I was really focused on doing some Apple basic stuff. But if you're new to the Coding Train, hopefully these videos can still, if you haven't had a chance to watch them, you can find project ideas and inspiration. And for any of them, like if you decided you want to, for example, look at the Collatz conjecture video, you can find the code for it, any reference materials here, and then the Passenger Showcase. So for example, Spectral Piano made a Collatz burb in 3D. So look at it, it's like a Collatz, because it looks like a chicken or an eagle. That's really cool. It's made in 3D. So this is where people will share their projects. And if you're on the website and you go under the guides, there is a guide here for the Passenger Showcase and a form that you can fill out and submit. But let's see now if I go to, and if I go to the Showcase page itself, this is just like all of the Passenger Showcase projects. And you can page through all of them. Would be, now I think is the time the website's settled in a bit, would be nice to be able to sort these by other means. But currently they're sorted by time, or I could go to any particular. I was looking to see if Lost Sorcerer is not on here, but I know that Kathy's page is usually the one I go to as an example. You can kind of collect all of your showcase pages. In essence, like this is not the intended behavior of the website, but it's a little portfolio page for you. Okay, so let's go to the home page, and we'll see here. If you happen to be watching right now, and you've never programmed before and you want to learn the basics, or if you more shaders, WebGL content, yes, Nicole, I would like to, that's a great goal for 2024. And you would like to learn to code, or maybe you know someone in your life that you want to share your love of coding with. These right now on the home, these featured tracks are the 2 beginners ones. Code Programming with P5.js are all of my beginner tutorials of programming in JavaScript with P5. And I more recently made a video about learning to code with processing. And this is actually, instead of being a sequence of videos, it's actually just one 5-hour full course that you can watch. So those are there, featured challenges here. And then let's look at some Passenger Showcase projects that have come in recently or curated by Kathy. So I don't know if these are the new ones yet. We'll find out. Maybe we'll get to look at it. So let's look at this bouncing ball from Mauricio Fernandez. Look at this. Okay, so first of all, Space Monkey, who you maybe go by, Mauricio, fantastic work. So this is one of the challenges I give in the beginner course. So I'm guessing that maybe Mauricio just learned to program. We should all give Mauricio a huge round of applause. Good job for learning to code. And one of the first things in my video courses that you learn is how to make a circle bounce around a canvas, changing direction each time it hits the edge. And it looks like Mauricio here added a wonderful new feature, which is for it to change its color every time. And we can do a quick code review here. We can see that Mauricio has some global variables. I should really be logged in. Let's log in here as the coding train. I usually like to go into the high contrast mode and make the code a little bit bigger. We can see here that, look, to me also, like, nothing makes me happier than seeing code comments in another language. So that is really wonderful. I love that you're using your native language also for variable names. And you can see here that based on the bouncing, a new random color is picked, and that random color is used to draw the circle. Okay, here's my quibble. Here's my, I wouldn't call it a criticism, it's an opportunity. This is my, this is my pet peeve. You know, I'm having trouble reading this code because of some of the indentation. So you can see how the if starts here, then what's happening in the if block is indented over here, but then this curly bracket, it wants to be right here so badly. We just want to like pluck it, move it, pluck it, move it. Can't do it. But guess what? Oh, thank you, P5 web editor. Edit, tidy code, edit, tidy code. Oh no, what's going on? Wait, what's going on here? Why is it not tidying the code? Oh, it did it now. I don't know what just happened. Some temporary glitch. But now it tidied the code, and we can see, to me, I know I'm being silly, and it seems silly, but these are the kinds of things that over time help me to, at a glance, understand how code is structured and what it's doing. So even if it doesn't really matter for the end result, developing a habit of a style that you conform to, whether you prefer the spaces or the tabs or the 2 or the 4, all of that is welcome here. We are a tabs and spaces inclusive community here on the coding train, but I do think it's helpful to conform to some of these standards to help readability. But I would really commend you on putting comments into your code, on the way you named your variables, and just getting this to work. Great job, Mauricio. Okay, let's take a look at this. One of my favorite algorithms is the flow field algorithm. And we can see here that Adores Coding, which is a great GitHub name. Oh, look at that. That is wild. So this is using a flow field as well as maybe the direction. I definitely have said these words to my students in class of like, what if you took a flow field and had the direction of the vectors be related to the pixels of an image? And perhaps even a video here, and you can really see that happening in this incredible project. I guess, is it actually taking this image of the Mona Lisa, or is this a live video? I'm not sure. But this is really fantastic. And by the way, excellent documentation to have a README that sort of explains what's going on, has an image in it. This is really, really fantastic work. I'm wondering what the sine wave is. I guess it just, maybe the flow field follows something of a sine wave when it is not part of some pixels that are part of a mask or something like that. We could dig into this more, but I think just looking at it as an inspiration is wonderful. Great work to Ethan from Adores Coding. This is really hard. Got to get my regular trainer. Okay, terrain generator with open simplex noise. Open simplex noise, another one of my favorite algorithms. I've been seeing a lot of these. So this is I've been seeing a lot of these, like people making little renders of their generative art sketches, their P5 sketches, and posting them as YouTube shorts. So this is what I was thinking of doing for the January month. But you can see here, I love this idea. So open simplex noise is a particular noise algorithm with smooth randomness, and it can exist in different dimensions. And to me, what this looks like is it is two-dimensional noise, but the noise values are being used to extrude the height of a 3D in a sort of 3D terrain. And so this is quite similar to if you wanted to learn how to do something like this, where do you get started with this? If I went to thecodingtrain.com under challenges, maybe search for terrain. I can see it updated now. The new feature challenge updated under terrain generation. This is my coding challenge video with building a, oh, look at that young man there. No back problems. I mean, I don't know. I think the silver is quite nice. Fetching. Did I use the word fetching to describe myself? That was not a good idea. I'm getting a little woozy. The talking straight for an hour. It's time for my break and time to do some coding. How's that poll going? Oh wow, 51% on the Wolfram. So we're gonna have to see. I might go with the Transformers.js, honestly, if there's not a huge movement towards the Wolfram stuff. Okay, so thank you for sharing that to Alpa Lonez, and apologies if I'm not pronouncing. By the way, I often pronounce a name, then I say apologies, and I genuinely mean, for if I am saying your name, whether I got it right or wrong, I would love to hear from you. Either to say like, yeah, you pronounced it correctly, thank you, or this is how you pronounce it. You can send me an audio file, a link. That way, as I get to know more names, I'll get better at it. Okay, let's see. What do we got here? Let's refresh this page. And we have 3 more. See, that was the lucky thing about not merging that pull request before I started. Let's look at 3 more. Reaction, I'm going to go through these kind of quickly so we can get to taking a break and doing some coding. Reaction diffusion heart shape. So one of my favorite algorithms is reaction diffusion, also a coding challenge. Coding challenge. And it looks like this is using the contours of a heart as the initial values. A reaction diffusion algorithm, you can think of it as like this almost like petri dish that I'm like pouring a chemical into one spot and it propagates around that petri dish. Really, this works like a cellular automata. Each pixel has a state and its state changes based on its neighbors, and we can see what emerges from a heart. Thank you, Encore. This is wonderful. I think I already commented here, so I was going to comment on it again, but everybody give Encore. Oh, look at this. I thought like maybe the heart will be lost, but we're really getting the heart back here. Okay, pretty interactive double pendulum from Harun. Let's take a look at this. Wow, so this is a whole like interactive web page, and I can change the mass of the different bobs. I can alter their length, and I can play with the gravity. Let's make gravity really strong. And oh, we got to have the trail. The whole point of the double pendulum is to have the trail. So maybe I need to make these later. How can I get it to swing much faster? Can I grab it? This is really awesome. So let's refresh it, and let's turn the trail on. And yeah, so this, the double pendulum is one of these incredible chaotic systems that, I have a video which goes through the sort of motion formulas to model it. You can also kind of create one with a physics engine like Map.js, maybe P5 Play. But the trails that it makes are just, I find them to be quite beautiful and surprising, etc. All right. 2 questions I'll answer here that I see in the chat. Viking the Dude says, is Daniel on Twitch? Primarily not doing very much these days, to be perfectly honest. Thank you to all of you who support the coding train, even in this reduced amount of content, if you will. I do have a Twitch account. I was using it for a while. I was going back and forth. I probably haven't streamed on Twitch in well over a year, if not longer. So never say never, but not using Twitch too much. And then Sadra is asking about MD, and thank you to Lost Sorcerer who is answering it. It is a markdown file, a particular kind of format for creating a document, and it's a standard across a lot of different systems, and GitHub README files, text files, documentation files usually use that markdown format. Okay, so I'm going to take a break now, short break. I will remind you, actually what I should do is I should take a break. Well, it's like you can use the Turing Tumble as like, oh, this is the wrong, oh look, this is the top of my coffee. I can't let this is me with the green screen. I think my lights might be a little bit bright today. I don't know. I can't. There we go. No, wrong screen again. Whiteboard. There it is. Just remind you of why taking a break. If you want to take a look at the upperstory.com/Turing Tumble, thank you to the sponsor of today's episode. Link in the description. The Coding Train code will get you 10% off. If you missed my segment earlier in the stream, you can go back and watch it after the stream is over to see me playing around with and enjoying the Turing Tumble. So I am going to go to my intermission screen. Noor Mohammed Shiglar asked for a neural network series. There is one. It's recorded quite a while ago, but if you want to just learn the basics of a sort of vanilla neural network, it's all there for you. You can find it. Maybe somebody in the chat can help. I think it's even on thecodingtrain.com under a track. But let me put on a little bit of music to take a short break. And when I come back, in less than 5 minutes, I will program. I think I'd like to look at Transformers.js. So I think that's what I'm sort of planning to do right now. All right, I'll be right, and we're gonna make a clustering example. Okay, I'll be right back. Short. Right, I am back. I turned the heater back on because I noticed it's getting quite cold in here. And it is 12:10. So The heater feels very loud to me, but I have a feeling it barely comes through for you. So let me know if there are any audio issues you have in terms of hearing me. I also haven't heard from anyone that the popping or rubbing sound that I think was happening because of the way the lapel mic, the lav mic was rubbing against this sweater, um, was occurring. So that seems to have gone away, but let me know. I'm also been a little weary. I think the cold. I didn't realize how like cold it was getting in here, so my energy is like I took that break. My energy is a little bit low, but hopefully things will warm up in here, and I am excited to talk to you about some new stuff that I have been exploring with my teaching this fall, and I would really like to. It just hasn't happened, but in an ideal world, I would have been making video tutorials all alongside in parallel to the teaching I was doing at NYU, which is what I have done in past years. But the Nature of Code book, that's been like, I'm like teaching my new material at NYU, and then the time when I'm not teaching that, I'm working on the Nature of Code book. So in past years, I'd be teaching my new material at NYU, and in the time when I'm not teaching it, I'd be making videos on that same topic, and that seemed to work well. It isn't happening, but we'll see. The truth of the matter is the landscape of what's possible with a lot of the new techniques and technologies for generative text, which is what I'm exploring in my class this semester, is all changing so rapidly that, I don't know to what extent making a lot of videos would be that useful anyway. But I might as well give you a little peek into that during this live stream. And if there is interest, I would love to come back and do more content about it. So where to get started? There is a GitHub organization called Programming from A to Z. It's not an actual organization. That's just what the thing is called on GitHub. And that's where everything is for the class that I'm currently teaching. And the syllabus for that class is under here. And I can just kind of like look at an overview of it. And if you were to go all the way up to week 8, this is all, and I realize my desk is it higher than it usually is? I'll just bring it down a little bit, although that might cause me other sorts of issues. But if you go through all the way down through week 8, these are things that I've actually already made a lot of videos on, dating all the way back to like 2015 or 2016, I think, when I did a lot of these videos. There is 2 weeks here that I spent in my class where we looked at different social media platforms that you can use their APIs to create a bot. And in particular, I focused quite a bit of time on Discord bots. And in case you happen to miss that and you're interested in learning how to make a Discord bot, the most recent new videos that I made, which was just in the last month, which are here, are, one is coding a Discord bot. So if you've ever wanted to make a Discord bot, a little bit of JavaScript, a little bit of programming, this video will give you all of the basics to get your first bot up and running. If you've never, and Thomas P, thank you. Thomas P, I am going to tell you about the videos that I've made. But if you've never used Node before, then this video will also go over how to set up a Node project. And one of the things that I did in that video that I haven't covered anywhere else is looking at ES imports. So if you've never used import statements in Node, that is helpful for you. And then a little bit of an update. My arm won't extend all the way over there, about some of the workflow tools that I'm using, Terminal, Shell, VS Code, etc. I mention these mostly because, not that I pay too much attention to this. The Lost Sorcerer, sorry, let me get to your question. If you tag me in Discord and I can answer it there. Yes is the answer, but I have to dig it up. It's like a P.O. box type thing. These videos were very barely watched, which is very understandable. because they're meant to be resources that, at any moment in time you might need. Like, who's waking up in the morning to be like, well, what am I going to watch while I'm eating my breakfast? I don't know. How about coding a Discord bot? But I do mention them in case people didn't see them and are interested and want to kind of like mark them for watch later or go back and look at them. Feel free to. Okay, so the thing about the heat is, even though you're not hearing it, it's very loud in my ears and it's causing me to talk very loud, which is, I think, putting a strain on my voice, but I'm going to just try to be more mindful of that. I do see a little bit about mentioning that there might be some issues with the audio. So if other people are having audio issues, please let me know. Okay, so back to this. Now, the new stuff. The new work that I've been doing just in the last few weeks is making a set of examples and content related to working with transformer models. So what is a transformer model? Let's just talk about that a little bit. Okay, so for me, predictive text all starts with this idea of a Markov chain. It's going to take me a while to get to where I'm going, but I feel like this background is important. So this idea of a Markov chain is not related to text. A Markov chain refers to a sequence of states. Weather could be a Markov chain. Raining, raining, sunny, 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 raining, sunny, sunny, raining, raining, snowing, raining, raining, right? That is a Markov chain. And the idea of a Markov chain is, given a history of states or just the previous state, could you make a probabilistic prediction of what the next state would be? If it's been raining for 4 days in a row, is it more likely to be raining the 5th day or more likely to be sunny? And if we wanted to, we could do an analysis, but if we wanted to use a previous analysis to generate fictional weather, we could basically analyze historical weather, look at the probabilities of how things happen in sequence, and then generate new weather sequences based on those probabilities. And that's what's happening with a Markov chain with text. So if I were to think of each word as a state, or maybe the previous 4 words as the state, I might say, what would come next? Well, maybe there is an 80% chance that the word hat would come next. Maybe there is a 20% chance that I don't know. I was going to say litter box, but that's 2 words. So I'll just say litter. I don't know. Where is the cat? In the litter? Hiding under the washing machine? I don't know what would come next. But you could imagine if I were to analyze a huge corpus of text that was so large that the cat in that sequence appeared hundreds, thousands, maybe even millions of times, and then I just counted. Let's say it appeared 100 times, and 80 times, it appeared 100 times in the corpus, and 80 of those times hat was next, and 20 of those times the litter was next. Then I could use a Markov chain to generate text. Now, if I could magically make post-production things appear, I would now put up my Markov chain coding challenge video where I go through and program this whole thing. That video, I actually treat the state as a sequence of characters, not words, but you could have, word level, character level. Now, so why am I talking about this? Because I want to, for a moment, it's a very large leap. I want to go from this idea of a Markov chain all the way over to this idea of a transformer model. So transformer model is the deep learning neural network architecture behind systems like ChatGPT, the Llama model, and many, 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 many more examples. I'm just picking 2 that you might have heard of. The reason why I like to make this connection is with a Markov model, right, we would essentially create a giant table, a spreadsheet of every possibility, and then we could be using all of those probabilities to generate new text. A deep learning model is so big, essentially, the data, like we couldn't realistically build a Markov chain out of the entire text on the internet. Now, first of all, we should really be asking the question, just because we can, should we build transformer models that are essentially trained with, 10 years of chewed up internet? And it's not as simple as that, and there's lots of thoughtful people doing a lot of work that I don't mean to trivialize, but I do think this is an important question of, just because we can make these sort of ideas bigger, are they necessarily better? What is the social impact? What are the harms? All these are important questions. But I do think it's relevant, these things are out there for you, the person on the internet, to understand a little bit about how this stuff works and what it's doing. So how do I make this connection? I drew that line. I want to try to make this connection. I'm also sort of keeping an eye on the chat over there to make sure there's no messages. Put some siren emojis. Don't put them in there. Put them in there if there's something wrong. Don't troll me. I know you, internet audience. I'm only looking at the Discord chat. Okay. So first of all, the transformer model, and I'll point you to some resources that do probably a much better job of explaining this than I will, and I'm going to just hand wave most of it anyway. The input, if I had the cat in the hat, what a transformer model does, this is the input, and the output, no hat. The same thing, eventually somewhere I want to get this idea of predicting the next, and transformer models don't actually use words or characters. They use, as the individual chunks, they use something called a token. And you can read a lot about how is text tokenized. And, probably in and the are full tokens. But if I had the word computer, maybe computer is 3 tokens or 2 tokens, computer or computer or comput. Anyway, you can imagine it's not exactly like syllables. It's there's different techniques for tokenizing text. But for the sake of argument, let's just imagine that these were the tokens. Now, the idea of a deep learning model, and this goes across the board for most neural network-based models, is they exist because the solution space, the probability space, the space of the data is much too large to encode all of the information. Like with a Markov chain, I might literally have a spreadsheet again that has all of the possible sequences and all of the possible inputs and outputs. A deep learning model basically takes an input and then estimates an output. And you could go back and look at my videos on neural networks and all sorts of other material. But the idea here is each one of these, the reason why I'm getting to this is each one of these tokens, there's multiple steps. They're encoded first, but let's just skip some steps here and sort of think about them as an embedding. So, and let me come back to the computer for a second. And I'm kind of jumping around here, and I don't even know if, I don't know what people are talking about in the chat, but so one of a video that I made many years ago, let's see if we can find it. This is 2018. I talked about something called word-to-vec. And word-to-vec is an embeddings model, essentially, where every word is tied to a list of numbers. An embedding is a fancy word, essentially, for a list of numbers. And there's a terrific resource from Alison Parrish that I believe I linked to here on my syllabus week about embeddings, along with those, which is all about understanding word vectors and thinking about, like, this is a really nice example of, okay, what does this mean? Well, how do we turn words into numbers? Well, what if we measured every animal based on a cuteness and a size scale? And then a lobster is essentially the embedding 2,15. And a mosquito is 1,1. Like very small, not very cute, and very, very small. Color is another really practical example of how words, the color red, can be associated with numbers, 25500. And I could do, in numbers, I could do mathematical operations with. That means I could say red plus blue, red plus boo, red plus boo, I said it again, red plus blue 255.00 plus 00255, that equals purple. So I could actually do things like dolphin plus crocodile equals 65, 95, and that's kind of like an elephant. 65, 90. Dolphin plus crocodile is kind of like an elephant. We learned something new today. So this is the idea. So neural networks, basically the idea is that if all of these, each one of these words can be turned into an embedding, then those embeddings can use like positional encoding and some other kind of like stuff to be made into like a single embedding. And I'm totally like skipping a lot of steps and oversimplifying. These can go into deep learning layers. Numbers are the inputs into a neural network. And there's this whole thing about an intention layer, and then just a regular old-fashioned feed-forward neural network layer. And there's multiple of these, but ultimately this ends up predicting an embedding, which is that next word, which is tied to what that next word that should be in sequence. So again, I should probably pull up like a more thoughtfully done internet diagram of this, but I wanted to briefly, leaving myself some time to do some coding, kind of establish this connection. So to me, I'm interested in transformer models for a variety of different reasons, but a primary reason is this idea of associating text, sentences, words, paragraphs with numbers. So if you've ever heard, for example, of this technique called retrieval augmented generation, a RAG, if you will, it's kind of unfortunate, terrible name. This is something that I've been experimenting with, the Nature of Code book. What if I could take a question, what is a fractal, turn that into an embedding, a bunch of numbers, search through all of the sentences in my book and find all the sentences that have similar numbers. I could cluster cluster text-based data. I could search for answers. I could do like a question, answer, search. So there's all sorts of outcomes that could come from that. And I would like to make videos where I maybe slowly talk about this stuff some more and go step by step through it. I don't know, maybe it'll take a minute to see if there's some questions in the chat that I could address. But ultimately, what I want to focus on right now is not the use of transformer models to generate and predict text, but the concept that's inside of transformer models that's very critical. There are other models that are trained just to associate embeddings with text. What can I do with that? Okay. Dolphin plus crocodile equals shark, says Zachary. Okay. So I'm coming back over here. And we're going to, I swear, we're going to do some coding. I'm going to turn the heater off because the noise is bothering me, even though it's not bothering you. There. It won't get too cold in the next half an hour. Okay. So I am going to, so I have a whole bunch of examples that I've been working on. Let's go to my Transformers.js examples. I don't know if this is up to date. Okay, it was, no, I don't know what's in here. Well, I have a passphrase here. I'm not sure why. Okay, so I am going to, I'm going to make something new, but I just wanted to kind of like have this available. Okay. So what I would like to do, actually, let me just run this example for you because, and the reason I'm not doing these in the P5 web editor is they require some larger data files and some other things that are kind of tricky to do in the P5 web editor. But let's just see if this works. It's going to take a minute because it's got to load the embeddings model from the internet. Okay. So what this example is doing, and I might want to like try to build this a little bit, but what this example is doing is it has these six sentences. What color's the sky? What is an apple? The sky is blue. What does the fox say? An apple's a fruit? I have no idea. And so what I'm doing with each in this example is I'm taking each one of these sentences and turning it into an embedding. And then I am calculating essentially a similarity score. And we can talk about what algorithms you can use for these similarity scores. But basically, I'm looking for how similar are each one of these sentences to each other. And if I look at it in the browser, one of the things you can see here is all along, this is a table, all along the diagonal, I see a white square. Because what is an apple, which is, and I realize you can't see the bottom here. So let's make this like this. I'll try to step aside so you can see it better. I can move this over even. Here, I'm comparing what is an apple to what is an apple. So the similarity score should be 1. Now I'm comparing what is an apple to the sky is blue, and the similarity score is 0.078. But what is this one here? Comparing an apple as a fruit to what is an apple, I don't get 1. They're not equal, but I get a fairly high score. So this is why I'm interested in embeddings. It is a mechanism that I could use with my own data. So I'm generally trying to lean into, focus on projects on the coding train that involve bespoke, custom, I'm trying to do a lot of things with Nature of Codebook, transcripts to my videos, working with data sets that I have ownership of and knowledge of, rather than just kind of arbitrarily play around with, these giant data, piles of text on the internet. So even though those piles of text were used to train the embeddings model, I'm interested in what those embedding models can do for us. Okay, anyway, so so what I would like to do now, and I probably should have done this other automatic because I don't really have a plan for this, is I would like to create a basic example where I have a bunch of these. Instead of doing this matrix, what I would like to do is try clustering these. In other words, I want to create a visual world of these sentences where the similar ones appear near to each other. There's a lot of steps in between from where I am right now and how I'm going to get there in the next half an hour, but let's see what happens. Okay, so I'm going to create a new folder I'm going to call it clustering. And the reason why I'm doing this, honestly, is this is what I want to teach about in my class at NYU this week. So if I can get a little of this work done and experiment with this idea, then I will do so. And I see, Kathy, you're giving me some good notes about some things that I've sort of missed explaining. So maybe I'll come back to those as I start to build a code example, which will force me to go through things a little bit step by step more slowly. Okay, so let's get an HTML file. And I'm just going to borrow this one from here, which has P5 built into it. And then let's make a sketch.js file. And I'm going to pull what I need from here. So here is a kind of an unfortunate truth, which will either make you happy or sad, depending on who you are. So in my life, programming and making things in JavaScript in P5.js, the popping was really loud. I don't know what to do about that. Okay, I'm going to try moving the mic. Let me make sure it's the mic and not the laptop. I'll mute that. That's the only other audio source going out through OBS. Sorry about the audio, everybody. Whew. But maybe it's the cold. I don't know what it is. Maybe it's just that I've been doing this now for an hour and a half and my energy is in, but I'm having some brain energy issues. So let's shake it off, everybody. As my good friend Taylor likes to say, shake it off. Okay. Now, so what I was getting at is I'm used to importing JavaScript libraries through a script tag in HTML. This particular JavaScript library, which is called Transformers.js, is only available as a module, which means in my code, instead of actually putting it in index.html, I am putting it up here as an import statement. Import pipeline from the CDN, the content delivery network, where this library is stored. So this is the equivalent of, putting like the P5 library here. The difference is instead of putting it in HTML in a script tag, I need to put it in my actual JavaScript file with an import. And if you've never used imports before, I do cover these in the video that I just referenced about making your first node project. Okay. Now, the first thing that I want to do is load a model, and I want an embeddings model. So, and again, I'm just pulling code from an example that I made already. So the way, oh no, not the summarizer, sorry. The way that you load a model with Transformers.js is by through this pipeline function. So that's the pipeline function I'm importing from the Transformers.js library. And I could I'm calling this an extractor. So an embedding, you can think of that as a features is another related word to embeddings. So essentially, turning text into an array of numbers is kind of getting at what are the features of that text, numerically speaking. And so if I want to extract the features, that is what an embeddings model does. So Transformers.js has a lot of different pipelines, and this is a particular open source embeddings model called Mini-LM, Mini Language Model, and it performs feature extraction. Now, because this uses async and await promises, oh boy, is that something you've never heard of? Do I have another set of videos here to, I don't have to sell them to you because you can just watch them on YouTube, but I have a whole set of videos about async and await and promises. But what this essentially means is this needs to be, I'm going to put this in a function. I'm going to call it go. You could call it main. And that function needs to be modified with the keyword async because it's going to have asynchronous code in it, like awaiting loading this model. I couldn't download the model files, but the Transformers.js will go and pluck the model from the cloud. I'll show you where the list of models are in a second. And now I have that model in the extractor variable. Just to know that this works, the next thing I want to do is I want to say, let's just have a sentence. We're going to say the coding train says choo choo. And I'm going to say the embeddings are await extractor dot. I'm hoping it's going to auto-complete it for me, but it's not. So I'll go back and look at the example I made before, which is, sorry, let me grab this. So I totally did this wrong. But we'll go back to our example that I'm making. So the output is I await the extractor. I give it my sentence. These are some modifications that have to do with how the embeddings are computed. Normalize being true, I think, gives me all the values in the embedding itself. Normalize between a particular range, either 0 and 1 or -1 and 1. And let's just take a look now at that particular output. So this is a very basic hello world. The pops happen when I move. Check the mic cable. Yeah, unfortunately, I don't really know what to do about this now, and I'm so close to being kind of done that I think it's just part of today's stream, and I apologize for that. But I've tried unplugging and replugging in the cable and doing different things. So unless somebody has an idea, another idea, I'm not sure what to do. Uncharged. No, the mic is fully, well, the battery is full. Let me try just putting this on the table and letting this not be like underneath my clothes. Let's see if that does anything. So the mic is just here. Maybe I'll even just put it over here. I don't know. This might be worse, but okay. Let's see if we can get this to run. So clustering is what I'm attempting to build here. And oh, it would be nice for me to call the function go, to have it happen. You sure you're not just hearing that fly buzzing around? Let me make sure, oops. Let me make sure I have a particular setting. So this is an important setting that I didn't notice that needs to be checked, which is to disable the cache while the devs are open. So any changes in my code, whoops, reload. Where am I here? Yeah, clustering. Let's add some console logs so we know this is going. Loading model. Model loaded. Let's see what we get. Okay. So now we can see here in the, so, okay, great. So this worked. The model loaded, and what I got is the embedding. The embedding is in data. It's an array of 384 numbers. So now I can say output dot data. Let's just take a look at this. And there, that's the embedding. So let's do another sentence. We're getting somewhere, folks. So first of all, let's call this function load model, and let's make the extractor a global variable so I can use it around in other places. And then I'm going to say go is an async function that's going to first load the model. And then we're going to say, I don't know what to call it. We'll call it await embedding of a given sentence. So let's make this. I'm going to make something visual here that you're going to be able to play with, hopefully in the next 20 minutes. So this will get a little bit more interesting. And then what the embedding function will do, call it embedding, and it receives any given sentence, and it returns output.data. So basically, I'm going to say the embedding 1 equals await embedding sentence 1. And sentence 2 will be the coding train says, whoops. It's getting cold in here again. And I'm going to get embedding 2, and then let's look at them in the console. All right, so let's see if this works. All I've done is I've loaded the Transformers.js embedding model. I have an asynchronous function I've loaded the Transformers.js library. Now I'm loading the particular model. By the way, is the mic static from the sweater? I'm only going to be colder now. I don't know where to, I don't want to throw, the ground is a little dirty in here. I'm going to put this on a shelf here. Okay. Yes. We're rolling up our sleeves, everybody. We're going to make, I have sentence 1 and the second one. Thank you. All right. Importing Transformers.js. Loading a particular model, the mini LM model, which is an embeddings model, asking for the embeddings for 2 different sentences and console logging them. Let's see what we've got. Okay, so great. Now, so just looking, let's just look. The first number negative 0.05. And the second number, negative 0.03. Maybe these are kind of similar-ish. But here's the thing. So how do I know whether these two sentences are similar or not? So I'm going to have to put this into my pocket because I'm going to walk back over to the whiteboard to talk about how we calculate similarity between two sentences. Popping is still there. I don't know. I don't know what to do. I'm so sorry, everybody. Okay. So, oh, my weary bones in the cold in the garage. This whiteboard. Oh, I need a new studio. I don't know. Okay. So, let's think for a moment about color. Let's think about color as a three-dimensional embedding. So maybe red is the number 25500. That's the embedding for red. Maybe rose, and I'm going to get this wrong because I'm not good at colors, has the embedding associated with it of 252, 10. No, let's make the green 0, and it has like a little bit of blue in it. I don't know if that's, and I don't know why I'm putting a semicolon there. So think about color as three values. Well, that exists then in three-dimensional space. I could consider what would normally be the x-axis to be the red axis, what would normally be the z-axis to be the green axis, and what would normally be the blue axis, the y-axis to be the blue axis. And so the color red, 255, would literally be plotted right there. So that's red. And then the color rose maybe is here. So in this three-dimensional world that I'm establishing, their similarity could be the literal distance, Euclidean distance between those 2 points. So Euclidean distance being the square, like is the same in 2 dimensions would be, a triangle. C equals the square root of a squared plus b squared. That is the distance between these 2 points. Has to do with the difference between their x values, the y values squared, and the square root because of the Pythagorean theorem. So Euclidean distance is one way to calculate a similarity score. Let's go do that. So I say this because sometimes you're like, oh, what crazy math vector library do I now need to do what I want to do? You don't need anything because I am going to say, let's get the sum of the squares is 0. Let's go through the entire embedding. And the difference is embedding 1 minus embedding 0. Oops, sorry. Embedding 1 index I minus embedding 2 index I. Obviously, we'd want to be in a larger system, we'd want to do this a bit more thoughtfully. And then the sum of the squares plus equal difference times difference. And then the Euclidean distance is the square root of the sum of the squares. So now let's look at the similarity score between those two sentences. People are still talking about the pop. I'm so sorry. I can put my sweater back on. Well, I'm running out of time. I want to get to the grand finale here. So okay. So we're getting somewhere with this idea of embeddings. Okay, square root is not defined because I'm just kind of imagining using P5. So let's do math.square root. Okay, so look at that. I got a similarity score, a distance difference of 0.62. Remember that. Those two sentences were 0.62 units away in 384 dimensional space, because this particular model returns an embedding of 384 numbers. Okay, just to prove the point here, what if I change the sentence? So the coding train says choo choo and I love oatmeal for breakfast. I'm assuming that these two sentences are going to be further apart than 0.62. We're about to find out. I have not tried this, but let's see. You know, in my mind, those two sentences are now more different than the previous two, but let's see. So remember, I got 0.62 for the previous one. Let's see. Yeah, 1.33. They're further away. So even just this basic, and this is happening, just in case you're wondering, there's no cloud stuff happening. I mean, I am loading the model from the cloud, but that model is running on device in JavaScript in the browser. So I've done a lot of videos on TensorFlow.js and ML5.js. I'm really interested in tutorials and educational material around on-device machine learning, where there is no required cost to, like, so you watching this, I could be doing a similar demonstration with the OpenAI API, where you would send your sentence to their API and you would get embedding back. It might be more powerful in certain ways. I mean, it certainly is in many ways, but it would require you, one, to send your data away, whatever those sentences are, as well as pay, you know, a cent, 2 cents, 3 cents for that. Now, again, I'm not some like pure soul. I mean, I'm using all these APIs and cloud services all the time. But I do think this is why I'm choosing right now to work with Transformers.js. It just runs right here on this laptop in the browser. And oh, thank you, Fatima, for you. I see that people are giving me some super chats, which is very kind. Unnecessary, but very kind. Okay, so I now I'm showing you a distance. Now, the truth of the matter is Euclidean distance is not typically used for high dimensional spaces. And let's talk about briefly why. Let's see if this paper towel works a little bit better. I don't know what I've got here. Let me wet it. Oh, I have like little wipes. Okay, let's try this. Okay, so why is Euclidean distance often not used? Well, think about 384 dimensions. What if out of all of those oh, and I didn't press whiteboard. Don't worry, everybody. I know you're going to tell me this in a minute. What if in that high dimensional space, that 384 dimensional space, all of the values, all like 383 values were really, really similar. But then that 384th value was wildly different. Well, Euclidean distance-wise, you could end up getting a very big number for their Euclidean distance just because they're very far apart along one dimension. But ultimately, we want to consider those things to be very, very similar. So another way that you can compute distance is referred to as cosine similarity. And there are many wonderful tutorials and videos online about that algorithm in particular. I don't have a lot of time here, so I'm going to give you like a sort of quick overview of what cosine similarity is. So let's just look in a two-dimensional space, and I'm going to have these points, right? So you can see like Euclidean distance-wise, and obviously in 2 dimensions, like Euclidean distance might be better than cosine similarity. But you can see like this point is kind of the same distance from this. But let's think about if I were to basically take from the origin a ray or a line segment out to all of these points. Another way that we could evaluate the points is by looking at the angle in between these vectors, essentially. Let's connect back to nature of code, right? So look at these. These 2 points, even though they're kind of far away, have a very similar angle. This point and this point, that angle is quite large. And think about this. What is cosine of 0? Cosine of 0 is 1. So if the angle were literally the same, they would have a distance, a cosine similarity of 1 being equal, essentially. If that angle is very large, the similarity score is, as it goes to 90 degrees, is going to approach down to 0. So, or 180 degrees. Yeah. So, so that's the idea of cosine similarity. And in high dimensional spaces, again, our brains can, at least mine can't, think beyond really 3 dimensions. But in a high dimensional space, if you're looking at that angle, that cosine similarity, essentially, that, analog of this 2-dimensional angle in that high dimensional space, that's going to be generally a fairly good way of knowing if 2 embeddings are similar to each other. Okay, so how do you do cosine similarity? Let's come back to here. I have one more thing. I'm going to be going a little bit over probably because I do want to finish this example. All right. So first of all, I forgot to tell you about the Nature of Code book. The new edition, it's going to be at the regular Nature of Code website soon enough. But the new edition that I've been working on for, I would say over 10 years, but really in earnest the last six months to a year, is here. And actually, it so happens that in chapter 5, under the path following segment, I have a whole section in the book on something called the dot product. And the dot product is related to cosine and is actually a way that you can calculate the angle between 2 vectors. So you can see I'm doing that in this particular example that's in the Nature of Code. And so this idea of getting the angle between 2 vectors and then taking the cosine of that angle extrapolates to higher dimensions. And because I'm kind of short on time right now, and I want to get to the clustering that I want to do, what I'm going to do is just go and grab the formulas. So these are the formulas that I made for a previous example, and I'll put them here into this example that I want to do with clustering. So you can see here that essentially I'm using higher order functions, but the magnitude also sums up all the magnitudes. I use the dot product, which I cover in that Nature of Code chapter. You can go and read. And then the cosine similarity is the dot product of the 2 vectors divided by the magnitudes of the 2 vectors multiplied by each other. And that's going to give us the cosine similarity. So I could instead, look at I'll just call it similarity equal cosine similarity of embedding 1 and embedding 2. And let's compare. Let's see what we get. Now remember, it's going to be inverted. Like the smaller the Euclidean distance, the more similar. The higher the cosine similarity, the more similar, because the cosine similarity between 0 and 1. Okay, and so similarity. Let's just look at that and see what we get. Oh, what did I? Similarity. Similarity. I don't know what I'm writing. Similarity. Oops. My fingers are getting cold. Okay, here we go. Okay, great. So those sentences aren't very similar. I got a score of 0.1. What if I go back to the coding train says whoops? And really, these you can maybe come up with better examples, but we should get a lower Euclidean distance and a higher cosine similarity. And that we did. Yay! Okay, so this was me talking about what is an embedding, how can I have an on-device machine learning model give me an embedding for any arbitrary amount of text, and then how can I compare 2 different arbitrary amounts of text. So what I'm saying to you is, what can you make with this? Could you, something that I would say like that you could build now is you could make a chat bot which has like 100 different possible answers. And when somebody asks a question, get the embedding of their question, and you find out of those 100 answers which one is most similar to that question, and you give that one back. So that could just be something that could be like a Hello World demo that you could do just to kind of get this idea. I also think that I should mention, I kind of glossed over this, but if I go back to Transformers.js, there's a lot more tutorials and information here about how you can use this particular JavaScript library. And then this is, the tasks are really what I'm kind of interested in. And the model that I am using, where is it? I'm looking for what feature extraction. So I'm looking for a model that can do feature extraction, but there are models in Transformers.js that can, caption an image, can do all object detection, all sorts of other kinds of things. So you might sentence similarity is basically doing what I'm doing here, but it's doing it for you without the having to compute the distance score and all of that. So there's a lot of other stuff that you can do. And what you can see basically is that you create a pipeline. Like if you want to do sentiment analysis, you have to specify the task and the model you want. And so, and then if I know that I want to do, like, I have an example that does summarization, that I want to do summarization. If I click on this, I think this will give me the models that I can use that are compatible with that. So anyway, this is not an overview of everything that Hugging Face has to offer and how it works, but I just wanted to show you the landscape of where you can find the Transformer.js compatible models and kind of link that up to what I'm doing here in my code. Okay, so how's the audio going? How bad is it? Because I'm going to do something out of time, but I want to do something high degree of difficulty that I definitely do not have time for. But let's see what we can get. All right. We'll do this in a really crude way. The problem is, what's really gonna cause me a problem is, I don't have time to go through all of this today. I'm trying to think of, maybe I should do the question. Let me show you what I was going to do. I can't get this. I'm going to have to work on this on my own. Join the Coding Train Discord, and maybe I can come back, make some videos about this. Because I wanted to do clustering. What I've been experimenting with is this incredible JavaScript library called UMap.js. Okay, let's come back to, this is where I'm going with this next. So I gave you a little lesson in embeddings and using Transformers.js. And you could make this project. I'm going to be working on this because I got to demonstrate it in class this week on Wednesday. So this example will exist at some point soon. All right. But I realistically can't build it now without being here for another hour or two. So first of all, this is a wonderful article called Understanding UMap, written by Andy Conan and Adam Pierce from Google Pair, which is People in AI Research. And so one of the things, right, I have to walk over to the whiteboard to just talk about it. I've been talking a lot about high-dimensional space. I have all of these words, all of these sentences that exist in high-dimensional space. You can do this with images too, by the way. You can extract features from images and plot images in high-dimensional space and look at their similarities, etc. All sorts of possibilities there. But every time I come to the whiteboard to do a diagram, I draw it in 2 dimensions because that's the way it's easiest for me to see. So what if, just imagine for a moment that I had a list of words or sentences, and each one of these, and I'll just call them A, B, C, D, E, F, G, was associated with an embedding of 384 numbers. These, this is where I was going with the example I'm going to make. These sentences exist in 384 dimensional space. And if I could just see them in that space, I could see the ones that are near or far. I don't know, maybe my mind would open to all sorts of new possibilities that I couldn't imagine. Just would be interesting. Wouldn't it be amazing? I can't see them in 384 dimensional space. How could I plot them, maybe, in 2-dimensional space, even though it wouldn't be true precisely? I would get some type of, visualization of how that data looks. So what I need to do is a process known as dimensionality reduction. I need to somehow take these 384 dimensions and summarize them into 2 dimensions. This is not easy. Okay, so there's one way I could do it. I could just say, why don't I just arbitrarily pick the first 2 numbers of each of these? And we could actually do that. We could plot it, and we could see, and we might get lucky, and that might kind of reveal something and be, or maybe I pick the 7th value and the 20th value. Maybe I plot them in 3D space, so at least I get to pick 3 dimensions. Could I average a whole bunch of dimensions together? Like, there's 384, so could I average like half of them into one number in the second half? What would that give me? Well, these would be starting points. That's like where my mind would go. But researchers and other people have developed lots of other algorithms, like PCA, which I think is principal component analysis, is one. TSNE, which sounds like a sneeze, but it's not, is another. I forget like which letters are capitalized. This is another algorithm. A more recent algorithm is called UMAP. UMAP is an algorithm that can take all of these high dimensional data and reduce it down into 2 dimensions. So in theory, I could see clusters of the like data within 2 dimensions. There is a wonderful project made by also researchers at Google called the Embedding projector. And this does precisely that. So this is basically taking a word to vec, like a list of 10,000 words, all that are, I don't know what the dimensions are, and essentially mapping them into, reducing the dimensions into 3D space. And so if I were to zoom in and start to look at words that are near each other, I might find things that are similar. It's a little hard maybe to see this. A different data set that might be better to look at is MNIST. So this is doing this with images. These are low resolution images with 784 pixels. So you can think of 784 dimensional space, and it's using PCA to plot them in 3 dimensions. But I could switch to UMAP. And now this is what the UMAP algorithm is going to do. It is now taking these 10,000 data points in 784 dimensional space. You can see that listed up here, 10,000 points, 784 dimensional space. And it's taking a little while, but now you can see it's clustered them. So we can see here the 6s are kind of all in a cluster up here. Here's the 5s and 3s are kind of together, the 8s. So this is the stuff that I'm really interested in making my own versions of these. I'm sorry that the mic is still a problem. I'm going to have to investigate this. Okay. I could switch this to 2D, which could be kind of interesting to see it. There are different parameters in terms of how the algorithm works. And clicking right here takes me to a page that explains more about the UMAP algorithm that I'd be thrilled for any of you to look at and understand and try to find ways to help explain the UMAP algorithm in friendly and accessible and approachable terms. I do find that this particular article, which has a lot of visual demonstrations, this is looking at another data set. It's called Fashion MNIST. It's a whole bunch of images of shirts and shoes and things. And this is what UMAP, and this is the TSNE algorithm. And it goes through a little bit about the theory, about how it's looking at nearest neighbors in higher dimensions, and then synthesizing that down into lower dimensions. So I'm going to show you very quickly an example I've been working on. Let's see. I don't know which one is the one that I want to look at. Is it this one? No. Sorry. It's not that one. Yes. So I have been experimenting. This is a particular data set from let's see. From I've referenced this in videos before. A GitHub repository called Corpora, and it's just a collection of a lot of interesting data files. A lot more to say about it, but and under colors, there's a few different data files. There's like a data file of Crayola colors. So this is a nice like way of demonstrating things with embeddings. Like I have words that are associated with embedding of 3 RGB values written as hex codes here. And so I think Deluxe is a paint company, and this is a particular data set as many. It's like thousands of colors, and each with their RGB values. So what I've done with this particular example is I'm using this UMAP.js library. And I'll have to come back and maybe do some more videos about this, or come back and continue this on a live stream if people are interested. Is I'm using this UMAP.js library to essentially, I can essentially just call like this function called fit. So data can be a giant array of embeddings, and then I can just call fit, and what it then gives me is that data reduced by dimensions. So let's go look at my actual code, and I'll talk you through. Let me just run it, and we'll first see what it does. So what this is doing, and again, this is like a known, we don't really need UMAP for this because this is just 3-dimensional data. But what this is doing is it's taking that 3-dimensional RGB data and flattening it and clustering it in 2-dimensional space. So we can see that, look at these colors that are all kind of clustered over here, these sort of dark green blues, and these kind of light pastel colors, and these here. I can run it again. It's stochastic, meaning it uses random seed, so it's going to be different each time. But we'll get some very similar results. So this is what's happening. What it's doing is it's loading that JSON file. It's putting all the RGB values into a big array. So if I look at the array, which is console log data, this is my big array of embeddings. It is 4,224 3-dimensional embeddings. And then I initialize the UMAP algorithm. These parameters, I want it to go down into 2 dimensions. The minimum distance and the number of neighbors affect the quality of what it considers sort of similar and not similar, and how it places them. I initialize that, and then step does 1 cycle of the algorithm, so I can kind of watch it animate because it'll take quite some time. And then out of that, I get the 2D embeddings, which now I can just plot X's and Y's. And so that's where, and I'm taking the original colors and filling them. So my idea, what I'm not going to build right now, but what I'm hoping to do next, as an example, and if anybody wants to try this and compare notes, come and say hello in the Coding Train Discord, is I would like to go take this. My goal is to have maybe maybe like 100 sentences. And then I would like to use Transformers.js to make the embeddings for those sentences. And then I would like to use UMAP to graph them, to cluster them. And then maybe I could have like a little interface where you type in a new sentence and it redoes the UMAP and finds its place. I don't know. What kind of generative poetry could you make by doing a random walk through this 2-dimensional clusters of sentences? So that's kind of where I'm going with this. So I kind of showed you the pieces here. I will try to, after this wraps up, document all of these pieces and put links in the video description. Definitely come if you want to help with this or want to ask questions. thecodingtrain.com/discord would be the place for you to do so. So I wonder, hopefully this was somewhat interesting for people. You're getting a little bit of sense. Again, if you want to follow more closely a lot of what I'm working on right now, which I would love to turn into some video tutorials, I just haven't had the time. You can definitely check out the Programming from A to Z syllabus. There are the Transformers.js examples are in a repo here. I have some other things that I'm working on with other different models and API services for accessing these models that you can find and poke around in here as well. All right. Let's look, before I go, let's look at my list of things that I wanted to do in 2023, and let's see what's real. I got a month left. I'm leaving to do some holiday traveling. Honestly, like the last time I'll be here in this studio is kind of mid-December. So I've just got a couple weeks left of either live streaming or recording some stuff. I would really like to do, I think I should do the Wolfram Elementary CA as a coding challenge, because that will go nicely with Nature of Code. So that's probably what I'll do next. I didn't get to any of this stuff. I did this. I kind of did this, but I don't know if, I was planning to do more Discord bot tutorials, and then kind of like nobody watched that video. And I'm like, maybe I will, maybe I won't. But if I would encourage, I want to do more with ML5. Yeah, so I'm looking at this. I don't know. You let me know what you think. Use Project Gutenberg and rewrite a classic based on similarity. That is a great idea. So loading a public domain text from Project Gutenberg, and I could take like a text, chop it up into sentences, and then like cluster them all. So that could be kind of interesting. That would be a great project if somebody could try to do. Yeah. So let's talk about Nature of Code book for a second. So this is the pretty much finished new version of Nature of Code book. It is all available online, P5JS examples, all the text is there. I would say, right now I can't, this is going to be a living document, but it is somewhat frozen in the sense that there's going to be a finished version that will go to print. So if you would like to support this project, there are two ways you can do that. You could actually, buy the Nature of Code book. This won't come out till the summer, though. It says May 2024. I'll be thrilled if it's out in May 2024. So this you can pre-order from No Starch. I think it's on all of the other kind of like book websites. Or you can, the GitHub repos have like a GitHub sponsorship associated with them, but I don't get into it. But I just want to let you know that's there. And the PID controller. Yeah, I wanted to do that too. Chepacro just watched the Word2Vec video. That's interesting. So I really like to continue that. That was my intention, like to continue that with some of these modern embeddings models, but I never got around to that. So let me just thank again Upper Story for being the sponsor of today's Coding Train live stream. Again, if you missed it, you go back all the way to the beginning of this stream after I'm done. I did a demonstration of this game called the Turing Tumble. It's a wonderful, if you're looking to find a gift for somebody who loves computers and wants to learn more about how computers work, and especially if they want to have an opportunity to do that away from the screen, away from digital technology, and actually, get their hands into the mechanics of how computers work, to learn a little about the history of computing. Alan Turing. Check out the Turing Tumble and Upper Story. The link is in the video's description. upperstory.com/Turing and then coupon code all caps Coding Train. That's all I've got. I will take any other questions as I say goodbye here. I hope to continue to see you all submitting projects in the Passenger Showcase, to joining the Coding Train Discord, to sharing your work with me, watching old code challenges if you like. I don't know, 2024. I hope that's a good year for making lots of content. I actually went through everything on this list except for the Wolfram thing. Kathy asked, how does UMAP compare to fastest nearest neighbors? I don't know. That's a great question. We should investigate that. My understanding is UMAP does a particularly good job of clustering things and doing it very fast and efficiently. Thank you, Mini Jimmy, for your kind comment. I'm just awkwardly standing here for another minute and 45 seconds because that's what I do. Let the timer run out. Just see if anybody else has anything to say in the chat before I go. I'll put my sweater back on. I hope people enjoyed today's live stream. I think I should, one idea that sometimes I think about is, what if I just forgot about like making edited videos again and just like live streamed once a week? Just worked on projects. GIF Auto says, I got stuck in full screen mode on Apple II and can't escape. I don't know what to do for you. Thank you, Nicole. Thank you. Thank you. Well, oh, is there another fundraiser? I think there will be another Processing Foundation fundraiser. Check with the Foundation website about that. Lost Sorcerer, you're welcome. I was glad to be able to show that. GIF Auto, can you get to the Discord? I don't know if this is a joke or serious because you're somehow typing into the chat, so you can't totally be stuck in full screen. But I don't know, force quit. Make an ML video editor. That's, I think, beyond the scope of what I can possibly do, but I like that idea. Live stream once a week. Yeah, I'd love to get back to doing that. My teaching schedule is less busy in the spring semester, so hopefully I'll get back to things. Oh, my song is running out. Goodbye, everybody. I will see you. Hopefully I'm going to see you again in 2023. Thank you for watching The Coding Train. I don't know if I'm doing this the way I should be doing this anymore, but boy, am I trying and doing my best. I will see you all soon. Goodbye. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot. This dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. I'm gonna say once again, here we go, sing it with me. It's the polar Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 Unicorns and rainbows and cupcakes. What else is there? Yes, kittens. Thank you very much. Kittens and rainbows and cupcakes. Notice that. Look what I get. I'm really losing my mind. Okay, let's do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens. Kittens and 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 kittens. feel just sort of like a nice feeling of relaxation. Everything's going to be okay today. Dream is not broken. It has not frozen. This is a wonderful thing. Okay, we're going to do it. I'm really getting to something. I need my sound effect. Unicorns and rainbows and cupcakes. What else is there? Unicorns and rainbows and cupcakes. That was invalid syntax. I forgot. There was one other thing here that I think is important that I will use continuously over and over again in all sorts of text generation analysis things. That I will use continuously over and over again. First thing I need to do is, yes, kittens. Kittens, kittens. I'm really losing my mind. Okay, we're gonna do it. Kittens and kittens and kittens and kittens. 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 Kittens and kittens and kittens and Das Vidania.